All right, and we are excited to bring you another daily edition of our space weather content. Some spectacular imagery to bring you today. By the way, I'm your host, Dan, aka smAsho, coming at you from the Smash News Network, least busted, naming news. So spectacular imagery today for sure. Lots more stuff to cover as well. You'll see some content you don't usually see in the daily space weather videos. Let's cut down the music and get back to the solar imagery, as again, it is pretty out of hand today. So there's 171 angstroms, a wavelength of ionized iron. Crazy filament dancing around in the northeast, active region in the northwest. Most of the activity in the northern hemisphere. And while we see overall low solar activity, we still have a coronal mass ejection watch in place. We can't control when they happen. We just report on the facts. So here's sunspot 2857, the only sunspot on the solar disk right now. I don't think the one yesterday even got named. I don't think it was there long enough. Not sure if it set in the southwest or if it evaporated. Here's some more imagery. We've got even more imagery at the end of the video. Make sure you check out the end if you're only interested in these incredible HelioViewer SDO movies. We'll run through a whole bunch of data. We'll have a cosmology segment today as well. Also, will be a separate video airing sometime after the daily space weather. And there will also be a meteorology segment, probably airing before the daily space weather. There was a little prominence down here. We didn't see any coronal mass ejections in the past 24 hours. Here's 304 angstroms ionized helium, and there are lots of filaments in between Earth and Sun right now, mainly around the eastern limb, but you can also see some minor prominences on the western limb. There are some filaments right in the Earth-facing portion of the solar disk as well. Again, only one numbered region, sunspot 2857. It's degraded since yesterday a little bit, mostly remained stable. I think it's still beta class. We'll examine that at the end. The 10.7 centimeter radial flux has actually dropped down. And we're heading back to a zero sunspot situation. There's the one-year chart of the radial flux, represented by this black line. So as you can see on the Space Weather Enthusiast dashboard, 73 is the number for the radial flux. No space weather storms forecasted. I would expect to see some raising of the KP index around here. So there are some coronal holes. I would expect to see maybe a little bit higher KP index. I don't think we'd see anything like a geomagnetic storm. Moving on. And we're going to look at global seismicity here. Current seismic activity moderate. That's a 90-day chart from volcanodiscovery.com. And let's consult the list at USGS. The area around the South Sandwich Islands still rocking in spectacular fashion. Also a deep quake near Fiji at a 5.4, nearly 600 kilometers depth for that 5.4 magnitude quake near Fiji. North of New Zealand, around Fiji. In between Fiji and Tonga, it looks like. South of Fiji. And indeed, Tonga, also a quake 289 kilometers southwest of that 5.8 magnitude at over 139 kilometers estimated depth. South Sandwich Island saw a 6.1. An aftershock of some serious rocking going on in the South Sandwich Islands region. Besides that, the Aleutian Islands saw some quakes, fairly calm considering the last couple days. Conditions seismically moderate. Let's look at volcanoes. I'm interested in what volcanoes are erupting. Are you? Well, we're going to tell you. Shivaluch. Little uptick there at Shivaluch as it's producing a 17,000-foot ash plume, a flight level 170 over the Kamchatka Peninsula. Abiko on Paramushir Island, still on the list, flight level 100, 10,000-foot ash plume there. Cherinkatan, 15,000-foot ash plume over the northern Kurils. That's south of the Kamchatka Peninsula, in between Kamchatka and Japan. Suwanosejima in the Ryukyu Islands, flight level 060, 6,000-foot plume of volcanic ash there. Don't fly your hang glider over the caldera. Mount Ibu exploding on the Isle of Halmahera. 7,000-foot plume of volcanic ash there. Mount Merapi erupting, 12,000-foot ash plume over Indonesia, flight level 120. Samisa-Pochnoi. Near constant explosions from the North Cerberus crater. I love the name. The Cerberus crater, producing an ash plume of 10,000 foot. The Great Sitkin volcano in the Aleutian Islands. Visible glow and near constant emissions of gas and steam indicate that fresh magma has been oozing out into the actively growing lava dome. So perhaps an uptick coming at Great Sitkin. Popocatépetl volcanic ash has dispersed in central Mexico. Fuego exploding in Guatemala, producing a 15,000-foot plume of volcanic ash over that nation. Revenador exploding, 15,000-foot ash plume over Ecuador. Sabancaya exploding, 26,000-foot ash plume over Peru. I would call that a volcanic uptick. And no matter how bad things get, folks, please do not attempt to pole vault the caldera, even if you're a champion pole vaulter. To quote Winston Churchill, if you're going through hell, keep going. smAsho keeps going. One of the things that keeps us going is our patrons. Thanks to our patrons. By the way, we put up public posts regularly on Patreon. You don't even have to pay for some of the content over at patreon.com/smAsho. Who knew? Hopefully you, the viewer, thanks again, patrons. If you think smAsho is the same as it was a month ago, think again. It's completely different. So welcome to the Neo-Renaissance and visit our links, support the channel. Thanks to the Smash team, let's get back to the GOES 16 X-ray flux. Part of the sun-facing suite of instruments on the workhorse, the GOES 16, showing us no solar flares here. So we have seen a reduction in the likelihood of major flares. No spikes in the proton flux here. That would be from things like coronal mass ejections. So we ain't got none. GOES magnetometer here showing some spiky patterns here in the past few hours. And for you new viewers, if you're wondering what these mean, that means noon, and that means midnight local time for the GOES 16. In other words, midnight, it's on the other side of the planet, opposite the sun. Next, looking at the current sheet of the heliospheric variety. If you want to read about the heliospheric current sheet, please look it up. It's a sheet of charged particles flowing out of the sun known as the solar wind, and it has polarity. It's got two portions. One portion is North Pole oriented, the other portion is South Pole oriented. And Earth has just recently moved into a North Pole oriented current sheet. Here's the latest image. You can see this green area, that's north, that is south. And those spiky sawtooth patterns you see on the GOES magnetometer are largely from crossing into the other polarity. Here's a line-of-sight view of the same data. It's gathered from 51 ground-based magnetometers, which are the National Sunspot Observatory, as well as magnetometers on stereo A and stereo B. Here's the line-of-sight coronal hole plot. And we do see some coronal holes that are just showing up here. I would note this one in the north. The last frame will be right around where I put the arrow there. So we're seeing a small intensification of coronal holes here, and a few days ago we put up a forecast for the next 60 days, a major precipitous increase in coronal holes. You'll have to watch our videos for the next 60 days to figure out if I'm right or not. And you'll find that I'm not incorrect very often. So next, looking at the solar flare probability monitor here and the filament monitor. And that looks like, I don't know if that's old data or not. I think that's actually, I don't know. That looks a little hinky to me, as it's not moving. But the likelihood of major solar flares is quite low. The likelihood of coronal mass ejections is still quite high. The coronal mass ejection watch remains in effect. Watch. There will be a coronal watch. There will be a coronal mass ejection in the Earth-facing vicinity in the coming short period of time. Within less than a week. Probably within less than 2 days. Anyway, there's the global geomagnetism update. It's a 3-day chart of global geomagnetism expressed in 3-hour increments, known as the KP index. Cheers. Next, real-time solar wind. And we've seen a very weak solar wind, weak to the point where it's producing error bars. You see these yellow areas down here? Those are error bars, yes, as the computer does not believe that they're seeing levels that are below 1 proton per cubic centimeter, although maybe we have seen levels that low. I really don't know. I don't want to get into it or make the video too long ranting about it. The BTBZ has recently moved into negative territory. Phi angle has recently shifted. Current solar wind density is just under 4 protons per cubic centimeter. Solar wind speed having just intensified over the past 3 hours here, now up to about 420 kilometers per second. Next, looking at the magnetohydrodynamic pressure around the planet. And magnetohydrodynamic pressure is measured in nanopascals. This is a model. It's the Space Weather Modeling Framework. If you want to read how it's derived, go to the Geospace Magnetosphere Movies page, scroll to the bottom, click on Details, and you'll find the Space Weather Modeling Framework links. It's a lot of data. That's 4 hours of it. And we have fairly low pressure from the diffuse solar wind. Next, ground magnetic perturbations. We show it daily. Maybe it'll freak people out less about the fact that there's a polar excursion going on. I don't know. I'm not frightened by it in the slightest. And we hope our viewers aren't frightened by it in the slightest, because it's not scary in the slightest. And there's no reason to turn on the rant cam for that. The rage cam will remain turned off. That's 4 hours of ground magnetic perturbations, the Earth's B field, and changes in it. Next, a diagram of the solar system. As Earth moves past Jupiter, I would remind all of our conspiracy theorists that the gravitational attraction, the pull on Earth between the Sun and Jupiter like this, is absolutely negligible. I heard one estimate that if all the planets were aligned, it would exert the force of a ping pong ball on the planet Earth. Anyway, that's where things are currently located. We'll advance this 1 week. Here's where things will be on August 25th. Full moon coming up on Sunday, the 22nd. So here is the star chart of what's going on above my head. If you want to build your own, go to in-the-sky.org, put in your location. Mine faces the south, as the ecliptic is that way. So is my desk and my sofa. Jupiter about to set, the sun about to rise in Lehigh Valley, Pennsylvania. Today's cosmology segment is going to be a completely separate video, so make sure you check it out. Again, it will air after the daily space weather. And thanks to everybody who watches not only our space weather videos, but the rest of our content. Next, looking at charging hazards around planet Earth, to not see any. Although we're seeing more moderate levels of electron flux, here's a 1-year chart from Solon.info of the electron flux. Yes, Earth is surrounded by electrons moving at very high rates of speed, like greater than 2 mega electron volts. And they've got a lot of energy. Here's the 3-day chart of them. These are measured at the F ionosphere layer, located at about 300 kilometers of altitude by the GOES 16. We almost reached warning levels yesterday, and I would expect to see warning levels reached today. So here we can see the forecast tends to agree with me. We'll be right near electron flux warning levels, which coincides with 1,000 pulse flux units, or in this case, 1,000 particles per negative squared centimeter. Here's a diagram of the Earth's Van Allen belts. If you're not familiar with the structure of those, feel free to pause the video. Distances are shown in miles. And here's the total electron content forecast, which will give you ideas of where we're going to see GPS errors. It's the whole air column worth of electrons. And since it refreshed, we're going to let it play through since we don't edit the videos. While I do pause these videos, the recorded ones, we do also stream them live. This one's not live. But since that updated to prevent us editing the videos and taking much longer to put up the content, we don't edit them. We keep it raw, to quote the Wu-Tang Clan. Here's another diagram of the atmosphere showing you distances in kilometers, temperatures of the thermosphere, penetration of electromagnetic radiation, and chemical concentrations in those layers. By the way, all your weather happens in the troposphere, and we do meteorology segments as well. That's yet another playlist, youtube.com/smashomash/playlists. Next, looking at the ionosphere. That's why we showed you that last image. This is about 300 kilometers of altitude in vibrational frequency. It's in many ways the bridge between Earth and space, where the diffusion of the atmosphere becomes very diffuse. 300 kilometers is well into space. Anyway, that's what's going on in the F ionosphere layer. Some minor anomalies happening here, mainly of the low frequency variety, if I'm correct. And we look at these daily because it gives us insight into the Earth-Sun environment. Anyway, there's the current state of affairs, some major low frequency anomalies there over the South Atlantic anomaly, which is, by the way, located here now instead of over the Atlantic. And shout out to Tamitha Scove. Here's the anomaly map in megahertz. That's anomaly from the 30-day median. And you can see quite a bit of low-frequency anomalies here, less so in the high-frequency range, but some of those occurring north of the South Atlantic anomaly. And we'll bring up the latest image here as well. That's from 12:15 Universal Time. Oh, that's 9:30 Universal Time. And you can see those low-frequency anomalies we cited on the actual megahertz chart. And if you're wondering what the wind patterns of planet Earth are doing, follow our meteorology segments. Another playlist at youtube.com/smashamash/playlists. So yeah, we did another meteorology segment today. If you didn't check that out, check our playlists, youtube.com/smashamash/playlists. Meteorology segments is one of the newer ones. Here come bonus features. So one thing I can definitively state is that these two large filaments were still intact by the time we were done recording the video. This imagery is only about 30 minutes old. You can see lots of filaments, lots of dark spots all around here. Filaments out here, prominences, etc. Coronal mass ejection watch remains in effect. Here's the latest GOES 16 SUVI imagery, showing you all of the solar features. Likelihood of solar flares low, likelihood of coronal mass ejections very high. Here's the latest intensity gram to show you what's going on with sunspot 2857. And you can see it has degraded just since I got up this morning. Here is the colorized magnetogram. We'll press refresh so you see that refreshed. And you can see it's breaking down. We're on the way back to 0 sunspots, unless something suddenly changes, which it can with respect to the magnetic environment. But low levels of solar activity. So again, filaments could eject. We don't need solar flares or sunspots to see coronal mass ejections, as our regular viewers are well aware. So here's the full disk once again in 304 angstroms. We got a nice prominence down here. That did not eject. We'll let that play through a second time. There's that nice little prominence down there. There is a little bit of an active region ahead of where that occurred. Here's just the northern hemisphere in this same wavelength. And ionized helium is great at creating enough contrast between filaments and the chromosphere, as filaments are in the corona, and the chromosphere is the colored part that we typically see in these images. So where you see a circle, that's the chromosphere. Where you see prominences, that's the corona. And the chromosphere is a thin layer in between the atmosphere and the photosphere of the closest star. And we'll close things out on some composite imagery. This is 304 and 171. Spectacular imagery here from HelioViewer, the Solar Dynamics Observatory. Just fantastic. Despite such low levels of solar activity, there could still be coronal mass ejections. And so our watch just simply hasn't expired. And we'll close out the video here on this massive filament. So now this is 304 and 193 angstroms. I just instinctively knew this would provide the most detail. And check out the three-dimensional nature of those filaments. What a fantastic set of images there from the Solar Dynamics Observatory. Shout out to NASA. Drop us a line. We'll interview somebody. Maybe everybody eventually. And to all of our viewers, friends, foes, science noobs, and science pros, thanks for tuning into the video. May that solar wind be at your back. please take a moment to press like and subscribe to the Smash News Network. Least busted, name in news.